Hi there, this is Prof. Johan from the Department of Chemical Engineering at the University of Pretoria. Welcome to my series on the Introduction to Chemical Engineering and Chemical Engineering Principles.
For us to be able to solve mass balances with chemical reactions, we first need to understand chemical reactions. And no, I'm not going to be teaching you about chemical reactions. That is being done and will be done in your chemistry modules. But I do want to talk about a few basic concepts regarding chemical reactions. Let's start with stoichiometry. Stoichiometry is founded on the law of the conservation of mass and comes from the Greek words stoichio and metron, which means element, and measure, so measuring elements. Now let's look at the following system to describe stoichiometry and chemical reactions. In the system, reagent A is coming in with stream A, reagent B is coming in with stream B, and reagent C, the product, is leaving the system in stream C. Let's, for this example, say that A is carbon monoxide, CO, B is oxygen. We're reacting the two with each other to form carbon dioxide, which is leaving the system in C. When we assume steady state, the total mass entering the system must be equal to the mass leaving the system. But looking at this example, we clearly notice that the moles in is not equals to the moles out, because we have 2 moles of CO coming in and reacting with 1 mole of oxygen to form the product of 2 moles of CO2. Thus, 3 moles are entering the system and 2 moles are leaving the system. What we do, however, know, and we can see from this balanced chemical reaction, is that the moles of carbon in is equal to the moles of carbon out, and so too for the oxygen. Let's spend a little bit of time on this. Why is the mass in equals to the mass out, but the moles in is not equals to the moles out? But the moles of a species in is equal to the moles of a species out. We know that the mass in equals to the mass out. But what if we take this mass in and we multiply it by 1 over the molecular mass of a single species? In this case, let's make it carbon. We know whatever we do on the left-hand side, we must do on the right-hand side. This now suddenly means we are calculating the moles of carbon coming in, and we see it's equal to the moles of carbon going out. So the moles of carbon in equals to the moles of carbon out, because we have the mass in equal to the mass out. And if we multiply both sides with 1 over the molecular mass, we end up getting that moles in equals to moles out. But this only holds true if the molecular weight used on both sides is the same. So it means for a single species. This number in front of the species in the chemical reaction is referred to as the stoichiometric coefficient, and we write the species as S. The stoichiometric coefficient has units of mole of the species per mole reacting in the reaction. We can now rewrite the chemical equation in a single line formula to describe what's happening. We can write it as the sum of the species, where we say the stoichiometric coefficient of the species multiplied by the species itself, added for all the species, or the sum of the molecular coefficient multiplied by the species, is equal to 0. But this only holds true if the stoichiometric coefficient of the products are defined as being positive and the reagents are defined as being negative, so that the sum of these products will be equal to 0. So for the example we had, the stoichiometric coefficient for the CO would be -2, for the CO2 would be -1, and for the CO would be 2. We do, however, also have a stoichiometric coefficient for instance, nitrogen, and this would be equal to 0. The stoichiometric coefficient for the nitrogen is 0 because it's not a product, which would have had a positive stoichiometric coefficient, nor is it a reagent, we would have had a negative stoichiometric coefficient. It can be in the system, but it's not partaking in the reaction, and for that reason, it has got a stoichiometric coefficient of 0. Any species additional to the species partaking in the reaction can be present in the system, but will always have a 0 stoichiometric coefficient. I hope you found this video helpful and are now a little bit better equipped to solve mass balances with chemical reactions with the help of stoichiometry.